This is our second lecture on NEET PYQ from laws of motion. So let's continue with our problems from PYQ of NEET, right? So let's start with our next problem. The question says the force on a rocket moving with the velocity. So velocity of the rocket here is given as 300 meter per second, right? And the force is given how much? The force is given here as 210 Newton. The rate of consumption of fuel. So how much fuel is consumed per second, that we have to find. Now we already know from Newton's second law, the force F equals to minus m dv by dt. But wait, here the mass is changing because the fuel is consumed, right? So minus v dm by dt. Negative sign is representing that the mass is decreasing with time, right? So force here is how much? 210. Velocity here is 300. And this will be minus dm by dt, how the fuel is consumed per second. So I am taking this 300 on the left hand side and it will become 210 over 300, right? That will be our minus dm by dt. And on cancelling, 0 cancels with 0 and we left with 21 upon 30. So 3 sevens are and 3 tens are. So we got here minus dm by dt, that is the fuel consumed, that will be how much? 0.7 kg per second, because on the left hand side, mass per second, dm by dt is, m is mass, the unit will be kgs and dt is time. So seconds, right? So 0.7 kg per second. So correct option is option A. Great. I hope you understood this, and you can see the complete playlist for this lecture series in the link. Let's see the next question now. Our next problem says a 5000 kg rocket. So mass of the rocket here is how much? 5000 kg. Correct? Is set for vertical firing. Okay, great. So let's assume that this is our rocket and it is going upward in direction. Great. The exhaust speed. So velocity of exhaust speed means velocity of the gases which are coming out of the rocket, that is 800 meter per second as per the problem. To give an initial upward acceleration. So upward acceleration A is equals to 20 meter per second square. The amount of gas ejected per second to supply the needed thrust will be how much, right? So okay. So one thing, let's figure out what are the forces acting on this. Clear? One is upward thrust. So let me write it as Ft. Ft is upward thrust, which is trying to make the rocket go up. And what is making the rocket to fall down back? The weight of the rocket, right? W. And the resultant force will be how much? So F net, the total force acting on the rocket, will be the upward thrust minus the weight of the rocket. I hope this is clear. And this net upward direction force will be responsible for mass times acceleration, and that will be equals to, what is the upward thrust? So it will be minus v dm by dt. Because of this it is going up. And weight, which will be mg. I hope this is clear. Let's take this mg on the left hand side. It will be mass times acceleration of the rocket plus the weight of the rocket, and that will be equals to minus v, how the fuel is consumed per second, right? So here I am taking m common out, and this will give us a plus g, that will be equals to how much? Upon v minus dm by dt. And we have to calculate this, how much gas, how much mass of the fuel is consumed per second. So we have to calculate dm by dt. Now how much is the mass of the rocket? 5000 kg. Let's substitute here 5000. What's the upward acceleration? 20 meter per second square. And what's the acceleration due to gravity? Sir, 10. Whole divided by the velocity. Velocity of rocket is, as per the problem, 800. So that will give us minus dm by dt. Great. So let's simplify it further. So I am just removing this 800, 0, 0 with 0, 0, while left with 50 upon 8, and 20 plus 10 is 30. Clear? Let's simplify it further. 2 4s are, 2 15s are, 2 2s are, and 2 25s are equals to minus dm by dt. I hope this is clear. Now 15 into 25, let's simplify it further. 15 5s are 75 and 15 2s are 30, 30 plus 7, 37 by 375 by 2. And that will be our, the mass consumed per second by the rocket, right? So let's simplify it. 2 1s are 2 and 16, 18, 2 8s are 16 and 2 7s are 14.5 kg per second. That is our minus dm by dt. I hope this is clear, right? So let's see if there is some answer like this. 187.5, option B is correct for this problem. I hope you are understanding it. If you have any doubt, just go through it, or any other doubt you can comment below. Let's see our next problem. Okay, great. Simple problem, class 9th problem. Question says a 10 Newton force, so F is equals to 10 Newton, is applied on a body, produces an acceleration. Acceleration is 1 meter per second square, right? The mass of the body. So m equals to force upon acceleration, and force is how much? 10, and acceleration is 1, so it will be 10 kgs, right? So 10 kg mass will produce that much acceleration when 10 Newton force is applied on it. So correct answer is option B. I hope you are getting it. Very simple, straightforward. Let's see our next problem. Great. Our next question says, if the force on a rocket moving with the velocity, so velocity of the rocket is 300 meter per second, and the force given here is 345 Newton. Okay, 345 Newton is the force, V is velocity given. Then the rate of consumption of fuel. So combustion of fuel or consumption of fuel, we know it's already F equals to minus V dm by dt from our concept of rocket, right? So F is given already 345. Let's take this 300 on the left hand side, and this will be giving us minus dm by dt. On dividing both the sides here with 3, so this will be 100 over here, and here it will be 3 ones are 3, 3 ones are 3, and 3 5s are 15, correct? So this will give you 1.15 kg per second. This much fuel is consumed per second. I hope this is clear. Clear? So this will be 1.15, that's option C. Okay. Let's see the next problem in this series. Okay, beautiful problem. Our next problem says, a satellite in a force-free space sweeps stationary interplanetary dust at a rate of dm by dt. The value of dm by dt is given how much? Alpha into v. Great. The acceleration of the satellite we have to find, right? So we already know the satellite is moving because of the same concept, F equals to minus v dm by dt over here. And what is the dm by dt? Dm by dt's are already given here as alpha v. So let's substitute. It will be minus alpha v square. That's our mass times acceleration of this satellite. So A will be equals to, acceleration will be minus alpha v square by m. That's our correct answer for this problem. So that is our option, minus alpha v square by m. That's option B, correct? Our next problem here says, a 600 kg rocket. So let me write here m equals to 600 kg rocket is set for vertical firing if the exhaust speed v is equals to 1000 meter per second, right? The mass of the gas ejected per second to supply the thrust needed to overcome the weight, okay? So let's see that our upward thrust must be greater or equal to the weight. So minimum thrust will be equals to mg, and this thrust will be, we have already seen in the previous question, that it will be minus v dm by dt, correct? That will be equals to mg. I hope this is clear. And they are asking how much? The mass of the gas ejected per second. So dm by dt, that will be equals to how much? Mg upon v, the velocity. So let's substitute here the values. M is how much? 600. G is how much? 10, and the velocity is 1000. So let's cancel out these 3 zeros with all of them, and we left with 6 kg per second. I hope this is clear. Option C is correct here, 6 kg per second. Clear? Let's see the next problem. Okay, so next question says, a ball of mass is here 0.15 kg, is dropped from a height h is equals to 10 meter, strikes the ground and rebounds to the same height. So let's say this is a ball, it is falling down from here, and it goes back to the same height as per the problem. The magnitude of impulse imparted to the ball is how much? Clear? Now impulse I is nothing but integration of force into time, right? When the function is given. Otherwise, if the momentum, it is change in momentum. So if we figure out the change in momentum, that will be the impulse imparted here. Clear? So change in momentum means first we have to find what is the velocity with which it is striking the ground. Now we already know the velocity with which it strikes the ground is root 2 gh. In case if you don't know, you can use equation of motion, and from that you will get the same thing. You can use v square minus u square equal to 2as. Okay. In case, let me explain you, v square minus u square equal to 2as. Initial velocity, it is a free fall, so it will be 0, and a is acceleration due to gravity, and s is the height, correct? So from there we get v equal to root 2 gh. Okay, great. If it is falling and hitting the ground at the floor at v equal to root 2 gs, it will go back to the same height. The velocity will be, we can figure it out, it will be root 2 gh only, correct? So v initial, mass into v initial minus mass into v final. But be very careful, the velocity magnitudes will be same, but the direction are different. In the first case, the ball is falling down. In the second case, the ball is going up, right? So here it will be how much? M is how much? 0.15. Let me write here 0.15. And velocity, which will be root 2 GH. G is how much? 10, let's assume. And height is how much? 10. Minus, when it is going up, I am assuming it as negative. So it will make it plus root under 2 GH. I hope you are clear with why I made it positive, right? So here it will be how much? 0.15, and that will give us 2 times root under 200. And this will give us 15 2s are 30. So it will be 0. How much? 3. And that will be 10 root 2. And this will give us 3 root 2. And root 2 is nothing but 1.141. Okay, so that will give us how much? 3 1s are 3, 3 4s are 12, 3 1s are 3 and 4 and 3 1s are 3, 3.423. That's approximately, oh, I think I have taken the root 2 value, there is a mistake, it's 1.414, not 141, it's 414, correct? So now when you multiply, this will give us how much? 3 4s are 12, 3 1s are 3 and 4, 3 4s are 12 and 1, 4.2, that will be our impulse, kg meter per second. So 4.2 is option B. I hope this is clear. Let's see the next question. Our next problem says an object flying in the air with the velocity. So what's the velocity of the object? 20 I cap plus 25 j cap plus minus 12 k cap, correct? Suddenly breaks into 2 pieces whose masses are in the ratio 1:5, right? So 1:5 means, let's say first mass is 1x and the second mass is 5x, correct? So before it gets broken up or it broke, okay, the mass was 6x, right? Okay, and it broke into 1x and 5x, clear? So be very careful. I am assuming that the mass was 1x plus 5x, which is 6x. Or we can assume in a different way that the total mass is, let's say, let the total mass be m. If the total mass is m, then 1x plus 5x, that will give us capital M, or 6x will give us m. So x must be equals to m by 6, correct? So the first mass is m by 6 and the second mass will be how much? Second mass will be 5x, that is 5m by 6. These are the masses before it gets splitted, right? Now the smaller mass flies off with a velocity this much, okay, velocity of the larger. So whenever such thing happens, we follow conservation of momentum, and conservation of momentum says the larger mass m into the velocity, which was 20I plus 25j minus 12k. This must be equals to, how much it will be equal to? Let me just put this whole thing down so that we can solve it in a much easier way. Here it is, okay. So this mass into velocity, the total initial momentum must be equals to the total final momentum. And what is the mass of the smaller piece, first piece? M by 6. And what is the velocity of the smaller piece? It is given 100I plus 35j. So let me just write here 100I plus 35j and plus 8k, correct? Plus, what is the second mass? We got it as 5m by 6. And we don't know the velocity, so let's call it as v dash, that we have to calculate. Let's divide the whole equation on LHS and RHS with m, so m will get cancelled, and we left with here as 20I plus 25j minus 12k. That must be equals to 100 by 6I, 35 by 6j and 8 by 6k plus 5 by 6 v dash. Just to make it little simple, let's multiply the whole equation with 6 also, so that this denominator 6 will go away, right? So this will become 120 I cap, this will become 6 5s are 30, 6 2s are 12 and 3 15, 150 j cap, and this will become 72 k cap, right? That must be equals to 100 I, 35 j, 8 k plus 5 v dash. We have to find this v dash, right? So let's take other stuff on the left hand side. So 120 minus 100, 20 I cap, 150 minus 35, that's 15 j cap, and 72, and that will become minus 80 k cap, that's our 5 v dash. So our v dash will be simply divide the equation by 5, and this will be 4i 3j, and that will be 16 k cap. Let's see if there is some answer like this, 4i 3j and 16. I have done some mistake here, it is 23. So where we have gone wrong, let's see, 35 and 150 minus 35, it is not 50 minus 35, so it will become 115, and when you divide with 5, it will become 23. That's our correct answer. So 4i plus 23 minus 16 k cap, right? So option A is correct for this particular problem. Let's see our next problem. It says a rigid ball of mass m strikes a rigid wall at 60 degree and gets reflected without loss of speed as shown in the figure. The value of impulse imparted by the wall on the ball will be how much? So first of all, to find the impulse, let's see how the momentum is changing, right? So for that, let's split our velocity vector. So velocity here is 60 degree, so here it is v cos 60 degree. Or let me just make it theta degree here. So v cos theta for the incident direction. For the direction which is going, okay, here it will be v cos theta, and for incident here it will be v sin theta, right? Similarly, for after reflection, v will be v cos theta in this direction, and the downward direction it will be v sin theta, right? Let's write the velocity vectors here to understand it much better. So velocity, initial velocity vector will be equals to v cos theta I cap, correct? And v sin theta going downward, so minus v sin theta j cap, it is going downward, okay. Similarly, v final will be equals to how much? V cos theta, but it is on the left hand side, be very careful. So it is minus v cos theta I cap, and downward direction minus v sin theta j cap, right? So let's see what will be the change in momentum. So change in momentum will be delta p, that's our impulse imparted, that will be our m v final minus m v initial, correct? And v final, let's substitute here, m let's taking common, v final will be minus v cos theta I cap and minus v sin theta j cap, correct? And minus, putting a bracket to avoid mistakes, v cos theta I cap and minus v sin theta j cap. So when you open the bracket, we can see here that sin theta gets cancelled with sin theta, and our v cos theta is left. So we left with 2 v cos theta I cap, correct? Okay. So that will be 2 mv minus 2 mv, and cos 60 degree I cap along x axis. So I am just removing, just putting the magnitude. So we will put the magnitude within a minute. So this will give us minus 2 mv, and cos 60 is half I cap. So this will become minus mv I cap, and finding the magnitude of the impulse will be equals to how much? Change in momentum, and that will be equals to mass times velocity mv. So correct answer for this is option A. I hope you enjoyed this lecture. We will continue with the remaining problems from this chapter in the next lecture.